I'm Steve Turner, so I'm a solution architect within AWS in the UK. I've been there for about 2 years now. And so I've got a kind of general focus within AWS where I work with a lot of customers in the new economy and startup areas, but I also have a kind of key interest in the AI and machine learning space. And so in terms of what we're going to cover today, it's going to be, first of all, looking at how we can use SageMaker for fraud detection. So I want to give you a little bit of the history of fraud detection from my perspective, and this will be kind of geared towards the payment card industry, but really with fraud detection, you could extrapolate that to be a number of different areas, anywhere where there could be kind of undesirable behavior that you want to identify and classify, you could use this for. And I'll mention a little bit about machine learning within Amazon itself, and then talk a bit about the kind of underlying architecture of SageMaker, and then finally give you a bit of a live demo. So in terms of payment fraud, it's a kind of ongoing concern for a large number of financial services organizations. And there was a Nielsen report that was published last October where it said that in 2016 there was almost $23 billion of fraud losses globally. And based on their data, they project that that's going to be almost $33 billion of loss in 2021. So it really is a huge area that has got a lot of focus on, and there may be some people in the room today that actually implement their own fraud detection systems, and they might be on a rule-based version, or they might be something that might be using some machine learning services. So hopefully that will give you a bit of an insight into what's possible today, and to do it in a fairly sort of quick way as well. So in terms of fraudulent behavior, there's effectively, I'm looking at it from 5 different layers. So at the very top layer, you've got the kind of endpoint authentication fraudulent area. And this is really where you might have, say, a skimmer on a cache point. You might have a compromised payment terminal. It could be something where at the point of purchase. The second part is really looking at the behavior of customers. So we're talking about anomaly in a session here. And that can be in a normal behavior where a customer logs into their account. They might do something like they might check a balance, they might make a transfer, and then they log off. In a kind of fraudulent world, that might be run by a bot, and so the actions may be a little bit different. So they might log in, go immediately to creating a transaction, and then disappear. And so this is a second kind of layer where we're trying to identify different pieces of fraud. The third layer is, again, a kind of deeper and more complex layer. And this is where, for example, in this case, a fraudster could actually create a direct debit within your account. And normally, everyone in this room has probably got direct debit set up. They would typically come out once a month. With a fraudster, you might have hundreds of transactions in a month. So that would be some kind of anomalous behavior there. Then you can kind of go even deeper. And so this is where you've got multiple channels of the same account. So that could be across different account types. It could be your credit card accounts. It could be your current account. It could be a mortgage. It could be something else you hold with the bank as well. And so they might be trying to commit fraud by manipulating these different channels. And then kind of the final sort of deeper layer is where you've got multiple bad actors across multiple different channels as well. And at this point, it becomes really difficult to actually identify what might be fraud and what isn't fraud. And, you know, in the more traditional sense of the word, the way you would try and pick up on this behavior is based on historical observations, and then try to create a bunch of rules which would be able to classify those. And so you'd have a load of rules maybe like this, where you'd be starting from things like, is my card over the limit? Have we got a sudden high spike in transaction rate? Is that card a known stolen card? Is the terminal compromised? And all these have to fit together to ultimately produce a decision which says, do we approve this transaction or not? Now, there's some shortcomings with that approach. You're using static rule sets, and these static rules become quite out of date quite quickly. So you're always behind. And these static rules, they might actually be error-prone as well. So the rules that maybe some of your fraud department have set up might not have been translated in the right way by the developers into the production environment. And it becomes very complicated. And you've also got to think as well about the issues with scalability. So it might work great, say 90% of the time. Come Cyber Monday, Black Friday, and so on, what happens when you suddenly get 5 times the amount of people coming to your website and trying to process a transaction? If your website falls over and people can't make their purchases, they'll go somewhere else. So we really have a set of requirements for a modern solution here. And what we really need is something which is comprises a set of dynamic rules, really. They've got to be acting in real time, and they've got to be self-learning or self-improving. And you know, these rule sets, they can become very vast depending on the amount of data that you've actually got based on your historical transactions. So you need some way of being able to maintain them easily. And then finally, they need to be scalable. So you need to be able to scale to, say, thousands or tens of thousands of transactions per second without actually having to put in any extra effort to do that. And so this is where something like machine learning can come in. And what I'm talking about today is a branch of machine learning. It's actually a relatively simple branch of machine learning. There's very many different areas that you could look at. The one I'm going to look at today is a form of classification, and it's called supervised learning as well. So this works by understanding the data set, and through the process of algorithmically training a model, it can start to understand hidden patterns. And the intention is you build a model based on those patterns, which you can then put data through to make predictions. And over time, you want that model to be continuously evolving and building and producing a more accurate model, which can make better predictions with fewer sort of incorrect fraud flags as time goes on. And so where does AWS fit into all of this? Well, you might have heard that AWS is having a major focus on machine learning, and our belief is really to put machine learning into the hands of every developer and data scientist. And this really is a focus from, say, an API-driven framework, such as Recognition and Poly, through to sort of deep-level data scientists areas where you're building your own custom models. Now, in terms of the history at Amazon, again, Werner mentioned this already, but there's been a long history of using machine learning within Amazon itself. And even back in 1995, when the website was first created, it had this recommendation system to promote new books based on your historical purchases. And that focus on machine learning is continuously evolving. So it's used in the fulfillment centers today to drive things like the Kiva robots to bring the products actually to the packers rather than requiring them to go out and find them on the shop floor. So that can really improve the speed to identifying a product and getting it packaged and sent out. It's being applied to things like Amazon Prime Air with the drone technology and using things like collision avoidance and computer vision to go and be able to autonomously send a drone out to deliver a package to someone. And then it's being used in other areas, so new product areas as well, like Alexa, and forming the basis of things like natural language understanding and being able to drive a richer user experience through voice-driven interactions. And then inventing actually entirely new concepts. So there may be some people in the room who've visited Seattle, and if you have, we've got an Amazon Go store there near one of the main offices. And what's really great about this is you can walk in there, you scan your phone as you go in, and you can pick up goods and then just walk out. There's no checkout involved. It's all based on various areas, including sort of sensor fusion, computer vision, and deep learning elements to actually understand what people are doing in the store. And then as you walk out, being able to figure out what you've picked up off the shelf and bill you accordingly. I've tried it myself, and I did try to take something without it billing me, and sadly I didn't manage to do it. It's a good way of seeing if you can take some kind of shoplifting challenge in there. But it does seem to be pretty accurate. And you know, today there's tens of thousands of customers running machine learning on AWS today. You've heard from a few of them already today, and they cover things like Babylon Health with their sort of health assistant. They cover things like real-time pricing of car data with Regit as well, and being able to help drive sales. There's a very vast number of different areas that machine learning is helping our customers today. And as I say, that can kind of go through the different stack. So we've got at the very top layer the application services, and I won't talk about that area today. I think there are some other talks today which talk a little bit deeper about things like Lex, Poly, and recognition. But what I'm really focusing on is the kind of platform services area and some of the frameworks which underpin that. So when we're talking about the frameworks and interfaces area, that's where we're really talking about the kind of data science territory where you're building your own custom models, and we're using different types of hardware to do that. So we've got things like our GPU instance types, which are the P3s. We've also got our Intel C5 CPUs as well. And these are some really powerful CPU-based instances which can be used to do both machine learning and inference as well. So it gives customers a lot of different choice in terms of what type of platform and instances they want to run their machine learning workloads on. And this then expands to things like IoT and also edge services as well. And that will include a vast array of different devices and different use cases. At the kind of bottom layer, we've got the P3 instances, the GPU instance types, and these are built on the Tesla V100 GPUs. And when you use our largest instance type, the 16XL, you can get access to a petaflop of compute. We've also got the Intel C5 instance types as well, and they've got 72 virtual CPUs available. And they can give you a huge improvement in performance using some of the kind of built-in machine learning libraries, which are part of the deep learning army that I'll mention later. And this deep learning army is a kind of pre-configured environment that allows you to quickly build deep learning environment applications. So this is kind of really at the bottom kind of custom layer. You take deep learning AMI. It's already got a bunch of open source frameworks built in, so things like MXNet, Caffe2, TensorFlow, PyTorch, Keras, Gluon, and so on. And you've also got a number of the drivers that you need to actually really take advantage of the AWS instances. So things like the Intel MKL libraries for deep learning, or the CUDA chips libraries as well. And these armies come in a couple of different flavors. The two main ones are the Condor AMI, which gives you access to a bunch of the pre-installed frameworks, but in Anaconda virtual environments. If you want something which effectively just gives you a framework to build upon, then I'd recommend using something like the base AMI. And this gives you effectively a clean slate where you can install the frameworks you want, but it's already set up to get you going very, very quickly on AWS to do your deep learning workloads. And so that kind of brings me to the platform services part, and this is really where the focus of my talk is today. So we often see that machine learning is still considered a little bit too complicated for everyday developers. And you've got to go through quite a wide number of different processes. So you've got to do things like collect and prepare your training data. And then you've got to choose the kind of algorithm you're going to use to actually start running your training jobs. You then might have to set up and manage your environment. So if you're doing a distributed training environment, you've got to spin up a bunch of instances to actually do that and make sure they're communicating. And then do things like training and tuning the model, and this can be sometimes an art. Some people at this point refer to it as not machine learning, but magic learning, because it's almost taking a bit of a trial and error approach to come up with the best parameters to actually train your model. And then once you're happy with that, you've got to deploy it in production, and you've got to make sure that it can scale and be managed so that when you're running this at a sort of large scale, you've got a large number of transactions per second happening, your model can cope with that, and you're not spending all your time having to add more compute capacity or more ability to deal with the amount of requests that are coming through and more resiliency. And so this is where SageMaker comes in. And SageMaker is really a managed service which is focused on providing the quickest and easiest way for both data scientists and developers to get started with machine learning and taking something from an idea through to production deployment. And it builds on this kind of pipeline that I mentioned before. So taking the first couple of elements, you've got pre-built notebooks. to solve common problems. And I'll show you a little bit of this in the demo later. You've also got built-in high-performance algorithms, and these algorithms cover a number of different use cases. So at basic level, you've got things like linear regression, you've got XGBoost, you can go deeper into things like convolutional neural networks, you can do RNNs as well, you can do natural language processing and understanding, you can do machine translation, and there's quite a number of different use cases out of the box that you can take the built-in algorithms to do. You can also take advantage of some of the built-in frameworks as well. So we've got the latest sort of stable versions of Apache MXNet and TensorFlow in there, and also things like Caffe, CNTK, and PyTorch available. So if you want to build your custom models, this is where a lot of the customers today are focusing on. If you're relatively new to the world of machine learning, you might look at some of the built-in algorithms and the example notebooks, and you can adapt these to just bring your own data and then start making predictions against that. The kind of next element is a training element. And so we say there's one-click training. And what we mean by that is you can set a model training, and all you need to define is how many instances you want to run it across, what kind of instance you want to run it across as well. So you could have a cluster of CPUs or GPUs running without having to do all the background work to set up that infrastructure. But you can also have a couple of parameters set as well in terms of how you might want to tune it. Or you could take advantage of the hyperparameter optimization. And this is already out there in terms of some of the built-in algorithms, but it's also in preview mode for some of the frameworks, and that will be coming shortly as well for you to use. And what that does is it takes your training job and tries lots and lots of different models at once with different parameters based on some of the ones that you've supplied to try and figure out what's the best approach and ultimately get the most accurate model that you can create. And then the last element is the deployment. So again, this concept of having a one-click deployment. And once you've got that model trained and you've done the work of running it and storing it in a sort of highly durable place like S3, you want to deploy it. You can deploy it simply by selecting the model and again saying how much power you want to give that model in terms of compute capacity. But you can also set it to be auto-scaling. So if the number of requests per second comes in and it starts increasing, maybe the CPU or GPU load starts increasing, you can have that auto-scale. And you can have that scale up and scale back. And you can also do things like A/B testing as well. So you can have more than one type of model being hosted on the endpoint, and you can weight the traffic accordingly. So you might have your production level model running and send 95% of the traffic to that. But then you might have some kind of test models that you want to see how well they perform, and you could send 5% of your traffic to those as well, and then use things like the CloudWatch metrics to monitor the performance of those. Another thing that SageMaker integrates with very nicely is AWS Deep Lens, and you might see a few of these scattered around the expo floor today. And so what you can do with Deep Lens is it's an Intel-powered IoT device, effectively, with a camera that can capture HD video streams. And you can take that and do inference at the edge. So you could build a model in SageMaker, and then you could deploy it and run it at the edge on Deep Lens. So what I really want to talk about now is how you might use SageMaker for fraud detection itself. And the way I'm going to start that is by taking a kind of a customer use case. In this case, it was Intuit. And what they're using is they're using SageMaker as part of their real-time fraud detection pipeline to be able to infer what might be an appropriate transaction, what might not be. And so that all starts with a Kafka cluster bringing in data, which is then piped through to a large sort of EMR cluster. And this is where today you still have quite a bit of work to do in terms of being able to deal with the raw data and pre-processing it to put it into a format that you could actually use to train a model on. This is where some of the challenges today come in. When you talk to some of the data scientists, you'll find that this is where a lot of their time is spent today. Once you've got that into a kind of suitable format, it's then sent into SageMaker to do the actual training. And one of the real beauties of using SageMaker for the model training is you're not continuously running instances all the time like you might be if you were running your own deep learning cluster. You submit a job, a training job, you specify how many instances you want to run it on and how long you want to run and what type of instance you want to run that training job on. And then it will run that training job for you, and once it's finished, it will just kill the cluster. So you're only paying by the second for the actual training that takes place. Once that training is completed, you stop paying for it. And this can be really, really cost effective when you're dealing with a large number of developers and data scientists who sometimes are not quite as disciplined when it comes to switching things off after they've been using them. So this can be really, really useful. And when you've got that model, it sits in S3. And you can do what you like with it at this point. You can either keep it in S3, you can deploy it on SageMaker, you could take it somewhere else if you wanted to. It's entirely up to you. It's a very open system. And in this case, by using SageMaker, you create what we call an endpoint, or host the model. And all we do with that is we say, this is the location of my model, this is how much power I want to give the endpoint in terms of running the model, and away you go. And it will build the rest. And then what you get presented with is effectively a RESTful API that you can make predictions against, and these can be in formats such as JSON requests. Now, the actual architecture of SageMaker is, this is pretty much it. This is something you'll find in the SageMaker documentation, and I'd really, really recommend, if you want to find out a lot more about SageMaker and its inner workings, you go through that documentation. There's a huge amount of information there that's far beyond the talk for today, but it talks about each one of the individual built-in algorithms. It gives you things like recommendations on the type of instance you might want to use to train those on. So if you took something like XGBoost as an example, that performs best on CPU instances, whereas if you're looking at a neural network model, you might want to think about using that on GPU instance types as well. And so with this model, in terms of SageMaker, so we've got a bunch of different areas here, and this is all built underlying on Docker containers. Now, what you'll find is in one of the talks later today, one of my colleagues, Matthew McLean, he's talking in more detail about this. He's going to talk about how you can bring your own algorithm and run it on SageMaker, and he'll be building a Docker container to do this. And this is where the system becomes quite open, because you don't have to just use what AWS provides you with. You can actually go on Git, and you can download an open source TensorFlow or MXNet container today, and then you can adapt that. You can install your own libraries, and you can run that on SageMaker. Or you could run it somewhere else if you wanted as well. You're not locked into any particular system here. It's designed to be very open. Now, as part of this, we actually provide SageMaker SDKs. And with these SDKs, you can actually run SageMaker even on your own laptop, and hopefully I'll be able to show you a bit of how that works later on in this, if the demo gods are looking after me. But effectively, everything is built on Docker containers, and that makes it very portable. You store your training code and your inference code in an Elastic Container Registry, so you can then make that very portable. You can upload your own containers into ECR there. And then it's brought into SageMaker itself. Those containers are spun up, and depending on how many instances you want to run in a training cluster, you just tell it, and it will do the rest for you. S3 is kind of like your single source of truth here. So what S3 is giving you is a place to store your training data, your model artifacts, the outputs of your training, and effectively anything that you really need to use in order to support your training job and your model is stored in S3. And this gives you a highly durable and available place to store this. And also SageMaker can then access that data. It can access it very, very quickly, and it can even stream the data in, so it doesn't have to do a very large bulk copy from S3. You can actually stream that data in to make the training a lot more efficient and a lot faster. And over time, as your sort of training set grows, you get more information, you get kind of a better understanding of how your model's performing. your training data can be put back into S3, and that can kick off a new training job within SageMaker. So you could use things like CloudWatch events to automatically trigger new training jobs on either a daily, weekly, monthly basis to keep your model up to date as well. So you can make a very automated process to do this and give you a lot of flexibility in terms of what you want to do in using SageMaker. And then ultimately you get this endpoint at the very top of the screen there. And that endpoint will give you an HTTPS URL that you can make predictions against. Now, in terms of the demo today, I'm going to talk about a linear learner algorithm. This is a built-in algorithm as part of SageMaker, and it kind of comes in two flavors. So you've got a regression style one, and this is where you can do effectively a real value prediction. So you might use that for things like sales forecasting, where you're trying to predict an actual number. You might be trying to estimate demand. And there's a bunch of sort of example notebooks out there, either on Git or built into this as well, which will take you through some of that. I'm going to be talking today about binary classification. And what we're wanting to predict here is it fraud or is it not fraud? So we're predicting a 0 or a 1 class. And that's where we're trying to take a lot of the observations we've seen and put it into one of the two categories. And what I would say is those of you who aren't familiar with, say, any kind of algebra and so on, don't worry about this. That's the only bit of math I'm going to be showing you today. So this is the part where it could all go either really great or really horribly wrong. And so hopefully the demo is going to go quite nicely here. But I'm going to kind of take you through how you might use SageMaker today. And I'm going to try and give more of a bias to using the console than actually going through a notebook and picking out different cells. Because I realize in a room like this, trying to sort of pick apart bits of code is going to be quite difficult for people to see. And that's something that you could do in your own time later by spinning up your own Jupyter Notebook instance and start looking at some of these examples. So I'm going to come out the presentation mode now and hopefully go straight into the demo. So if you open up your AWS console and you've got access to SageMaker through your organization or through your individual account, this is kind of the first screen you're going to see here. And so you get this dashboard view, and it shows a few different elements relating to SageMaker. The first one being you've got the notebook instances here. And so this is where you can, in a matter of minutes, have a fully managed notebook environment running in Jupyter that you can access and start experimenting and building with. And this comes with a lot of example notebooks where all you really need to do is bring your own data, make sure you've kind of formatted it in the right manner, and you store that in S3. You can then call it through the notebook and start doing machine learning on your own data as well. So there's a bunch of example notebooks covering a bunch of different use cases. I'll give you a very kind of quick overview of those as part of this demo, but I won't really focus on them. And so if you'd like to learn more about that, I really urge you to go and open up SageMaker, start a notebook instance, and start experimenting with that. Then you've got your kind of training jobs, and this is where you can monitor how well your training is going. You can see how long it's taken. You can get some stats based on how the training job is actually running through CloudWatch. You can pull out the logs in CloudWatch as well. So if you're running, say, TensorFlow or MXNet workloads, you can actually get those TensorFlow logs or those MXNet logs within CloudWatch and be able to see some of the deep level logging data that you would normally see if you were running this on your own managed instance. And then once we've got the models, they can just sit in S3. You can upload your own models. So if you've already built models that you've trained elsewhere, you can actually upload these models into S3. And you don't need to worry about the notebook instance or the jobs part. You can jump straight to the endpoint, and you can actually just take a model that you've already made and host that on an endpoint instead. And through that approach, it means that you don't have to buy into each element of SageMaker. You can pick and choose the parts that matter the most to you. So I'm going to show you, first of all, how easy it is to create a notebook instance. And so you click the element to say, I want to create a notebook instance. And then you just give it a name. So in this case, I might just call it demo. you can pick an instance type. And you've got quite a few to choose from here. You've got the CPU-based ones, so things like you can use a T2 instance. And there is even a free tier that you can use with SageMaker where you can get a number of free hours of training and using the notebook. So if you want to experiment with that, you can certainly do that today. You've also got access to the GPU instance types as well. Now, what I would say to you is think about what you're doing if you're experimenting with a Jupyter notebook. Because more often than not, unless you're doing an actual GPU-based experimentation, you don't actually need to run it on our P2 or P3 instances. An M4 might be more than enough just to actually run your example notebook. Because when you do the training job, that runs on a completely different set of instances that's separate from the actual notebook environment. So you could create a notebook environment on a T2 instance and run your training job on a load of P3s, and that's absolutely fine. Where the GPU instances can become quite useful is if you don't want to submit your training job, but you want to run it all in the notebook itself, and then you can experiment with it that way. So for the purpose of this one, I'm just going to pick an M4 type. You then have an IAM role, and all that IAM role is really doing today for what you need it to do is give SageMaker access to S3 so you can write data into S3 and access data from S3. You can also have things like an additional role to gain access to ECR, and you might do this if you're using your own Docker containers. And then you can run SageMaker either within a VPC or outside of a VPC, and you can be quite explicit now on whether or not you want to give it internet access or not, so you can actually make it quite secure. You can use KMS to encrypt your notebooks as well. Now, because this is demo, I don't care about any of that stuff, so I'm going to just click Create Notebook. And what it will now go off and do in the background is spin up effectively a container that's running the Jupyter Notebook instance. And this will take a couple of minutes to do. So rather than make you kind of sit through waiting for that, I'm going to use one that I made earlier. And with this one, all I really did was I spun up a notebook as I've just done here. And so I click Open. And this will take me straight through to the notebook. Now, this is just a very, very usual Jupyter Notebook environment, really. There's, if you're familiar with using Jupyter, there shouldn't be anything here which seems untoward or strange to you. When you start this up yourself, what you'll get is you'll get two directories in there, lost and found, and a sample notebooks directory. The sample notebooks directory is where you've got a huge number of different example notebooks that you can play with and you can bring your own data to and experiment with. And these can go from anything through using some of the Amazon algorithms to test against those. So you can do things like our blazing text algorithm, which does word to vec, or you can do things like deep AR for time-based workloads. You can do things like XGBoost or the linear learner, which I'm going to use today. You can do things like seek-to-seek for translation. So this one will take you through to an example notebook that actually allows you to do English to German translation. And so it's built on top of a kind of SOC-I framework. And if you want to learn more about this, just go and run this up and start looking through it. All you really need to do is effectively add your S3 bucket to it and make sure you've got the data that you need to use in order to start playing with that. So hopefully it's something which you can get going with really, really quickly and really easily, but then you can go rather deep into it and kind of start learning more and more about what's out there. So again, if you want to go into more sort of deeper level ones, we've got things like the advanced functionality ones. And so one of the things I think Matthew might show you later is about bringing your own Docker container. We've got things like TensorFlow and bringing your own model from TensorFlow as well. Some things using Redshift. And even using things like the built-in SDK, so using things like TensorFlow and doing that across a distributed set of instances as well, or using things like TensorBoard. So there's a large number of different ways that you can get going very, very quickly just to understand what's actually happening within SageMaker itself and hopefully help you understand more about the environment and what you can do with that. If you go into the documentation itself, then you can see the built-in algorithms here, we've got, I think there's about 12 now. They're adding them all the time. So the most recent one was random cut forest, and you can use that for things like anomaly detection. But they're being added all the time, and as part of these, one thing which is really, really useful is you get things like a recommendation on the type of instance to run it on as well. So it's, for each one of these algorithms, you'll get at the bottom a recommended instance type. So you can see, for example, with the random cut forest one, it's actually saying we recommend you run this on CPU instances like the Intel C5s rather than using the GPU instances, because you're not really going to get any benefit from that. So by all means, please look through the documentation. You'll get a lot of great information there. What I want to talk to you about as well is you've got access to these different sort of kernels that are built in. So you've got things like some of the PySpark environments, the Anaconda environments as well, so running things like Python 2, Python 3. And there you've also got the MXNet and TensorFlow kernels if you want to use those. Now, another area which is actually quite useful is it's got a built-in terminal. And by using this built-in terminal, you've got access effectively to a shell to your Jupyter environment. So if you want to do something like Git, you've got access to Git. So you can pull in your own notebooks from Git, your own data that you have stored in your Git environments today. All those commands are there for you to use now. And it's got other things as well, such as pip. So if you want to install your own libraries and frameworks, you can just do pip install, and you can do that as you normally would. So it's got quite a lot of flexibility in terms of how you might experiment with a notebook today, how you might want to add more things to it, expand it. And Matthew will also talk about how you can go into this in more depth as well, using things like the kind of life cycle configuration rules. So I've got a kind of fraud detection notebook here, and it's done. This is one that one of my colleagues built. He's called Cyrus. He's a super clever guy. If you ever get to meet him in one of our machine learning workshops through things like ML labs, really smart guy, and he builds a lot of kind of deep learning and machine learning environments and sort of custom build solutions to many problems. And so with this one, I'm not going to spend too much time going through the code on here, because I think that will kind of either it might interest some people, but it might also bore some people. And if you're at the back of the room as well, it might be a bit painful to try and make sort of sense of what's happening there. But effectively, you've got access out of the box to things like the Boto libraries. And if you've got access to the Boto libraries, you've got access to all the other AWS SDKs as well through Python. So you can call into Lambda functions, you can call into recognition if you want to, you can pull in different elements and add that into your notebook. Those of you who aren't familiar with things like Jupyter, you have this concept of cells. So each one of these code blocks is effectively a cell, and you can run that by just doing something like Shift-Enter. And when you do that, you'll see a number there that updates. And this allows you to kind of work your way through the notebook, try different things, experiment with different areas as well, and add different blocks of code. So if you added a block of code here, for example, where I'm defining my S3 location, and you messed up, and you got an error, you could actually go back and just run that code block again. You don't have to then try and run the whole thing. And what a lot of people use for these notebooks is to explore their data sets. They find that over time, it can be quite a challenge to get a large amount of the information and put it into a meaningful format. And as an example here, this notebook is using a credit card data. And that credit card data came from Kaggle. So Kaggle's one of the sort of really good places to get open source data sets from to experiment with. This particular one is a credit card data set. And so you get this normalized data that looks a bit like this, where you've got a time column, and then you've got a bunch of variables, which I've got absolutely no idea what those variables correspond to. They've been normalized, they've been anonymized, so you can't correlate them back to a particular transaction. But at the end there, you get an amount based on what it was, and you get a class. And the class is the part that we're trying to predict on. So this is a 0 or 1. And what it's telling me is whether or not this was a fraudulent transaction or not. And when I ran this and I looked at it previously, I saw that there was about 285,000 transactions here, and most of those were non-fraud, but there were about 500 which were fraud. And trying to pick those out can be quite a challenge. So this is where SageMaker would come in and use the linear learner algorithm to actually kind of process that and make some sense out of it. And what you can do is, I'm kind of jumping ahead a little bit, but you effectively set a training job here where you say, I want to build an estimator, and I want to define how many instances I have for that training job, what type of instance I run on that training job, and what my predictor type is. In this case, I want to do binary prediction, and then it will just go off and run that. And actually, if you don't want to do this in a hosted Jupyter Notebook environment, you can do it on your own machine as well. So we've released now some SageMaker SDKs, which you can run in a terminal. And I'm going to show you that next, and hopefully it will work. So what I'm running here in my own sort of little environment there, hopefully you can see that. I'm running a virtual environment just locally on the laptop. And I've got the SageMaker SDK installed in there. I just did pip install SageMaker. And then, so the next part, I want to run a Jupyter Notebook up. And again, this was something I have as part of my virtual environment locally. I've got a few other libraries like NumPy, Anaconda, Matplotlib, and so on. And so I'm going to start a notebook up. Now, with my AWS CLI, it's set by default to use a US region. I don't want to use that today. I want to use the island region. And so the way I do that is I just send a flag to it where I say AWS default region equals EU West 1. And then I run the Jupyter Notebook as well. So I just say Jupyter Notebook, and I'll run that in the background. And so that will then open a Jupyter Notebook environment. And what you'll see now is that's actually running locally on my laptop. So that's running on a local host port, in this case 8891. And this is similar to the notebook I just showed you. So I've still got the environment as I would do today. And I've got my fraud detection notebook here. And so I'm just running this locally today at the moment. And what I can do is I can experiment locally on my laptop. And then when I'm ready to actually call out into AWS and take advantage of things like a large training cluster, I can do that. So I just kind of jump through a few of the different elements to kind of set up some of the variables here. So in this particular case, I can actually do things like a list bucket command within S3. So it's communicating with S3 through my sort of own credentials, saying, right, here's the data for that. And I've already downloaded that data locally into the environment, so I don't really need to worry about doing the rest of this part here. But what I can do, hopefully then, is kind of define some of the location of the data within S3. So you could share your data with another person within S3, and you can just say where your data set is located, where the training is. And then the main element here is actually kicking off the training job. So I'm running within my notebook environment still. So if I go back to the dashboard here and I go to the training jobs, there's none actually running at the moment. Now, I'm crossing my fingers that the connectivity will work for me here. And that what you'll see is then it kind of kick off into the SageMaker environment. And so again, I've got this particular training job I want to run. And so I'm just going to execute that, and I get an error, so that's pretty good. And the reason I've got an error there is because I didn't run that one above it. OK, so what I did was I told it where the containers were sitting within ECR, and now I've got a training job running. And what you'll see, hopefully, if I refresh this page, is it going to do it? It is, yeah. So we've got an in progress now. So I'm running a training job on SageMaker that I kicked off locally on my laptop. And so that can give you a huge amount of flexibility in terms of how you can build your machine learning environments, how you can interact with them as well. And you can do things like look at the CloudWatch logs. I'm pretty much out of time now, so I can't go into any more detail about things like the endpoints. But what I will say is you can take things like the log groups within SageMaker itself. You can look at those in CloudWatch. And I'll take one I took earlier. And what that will do is it will give you the information you need to actually see how that training job completed. So this was one I ran earlier, and I've got all this output I needed for my training job. And then at the very end of that, I can also do a single call to build an API. And that API, again, is running a model that I just created and have that RESTful interface there to make those predictions against. And so I'm pretty much out of time now today, but I hope that gave you quite good insight into how you could build something quite quickly using SageMaker and taking something like the linear learner algorithm to get going very quickly to build a classifier. If you want to learn more, just run up a notebook instance, either do it locally or do it through the SDK, through the console, and go and explore some of those sample notebooks. So thank you very much for your attention.